And if oh,
Hi, I recorded my session.
okay, yeah. We will play the recorded version.
Thank you so much.
Thank you.
Greetings, esteemed colleagues. It's an honor to speak to you today and share the exciting work from my fellow researchers at the Biodiversity Heritage Library. Our presentation, entitled Unearthing the Past for a Sustainable Future, aims to be a compelling exploration into the depths of BHL's data ecosystem, telling the story of 6 researchers who are working to extract, transform, and load BHL's data to the places on the web that can maximize our impact. Because in a world where the urgency to address the climate crisis intensifies by the day, access to accurate and comprehensive biodiversity data has become not just crucial, but vital. The BHL is part of a global biodiversity data infrastructure, housing over 60 million pages of digitized literature about life on Earth. BHL encompasses centuries worth of biodiversity data that could be shedding light on migratory patterns, feeding habits, and adaptation behaviors. There's immense potential in BHL to provide actionable insights to scientists and policymakers who are working to shape a sustainable and biodiverse future for all. While this historic data holds incredible promise to advance our understanding of Earth's biodiversity, transforming 40 gigabytes of unstructured, uncorrected text into a usable resource has become an incredible challenge. Research explorations into BHL's dark data are the subject of today's investigation. It's important to note that not all BHL text files are created equal. Among the most challenging to locate are handwritten documents from past expeditions and collecting events. These primary source materials are rich sources of climate and species occurrence data. The uncorrected text in BHL's archival materials has had the unfortunate effect of obscuring hundreds of years of scientific observation. Species logs, maps, specimen catalogs, checklists, photographs, sketches, and more could enable us to trace the evolution of a species, understand ecological shifts, and devise better conservation strategies to bolster Earth's biodiversity. In contrast, accurate OCR found in modern publications empowers researchers in more ways than one. Thanks to BHL's ongoing partnership with Global Names Architecture, we are able to offer our users features like taxonomic search, species bibliographies, and interlinkages to 204 taxonomic databases on the web. And there's hope on the horizon for BHL's dark data. Recent advancements in text recognition engines, cutting-edge AI models, and innovative transcription platforms are changing the game. Here at BHL, we are finally beginning to unlock centuries of knowledge to advance our understanding of Earth biodiversity. Building a scalable data pipeline for over 60 million pages has required considerable time, investigation, and technical resources, but BHL staff remain committed to overcoming the challenge. Our global collective understands that the impact on conservation efforts will be immeasurable. Now it's time to transition to a Q&A style session with BHL's research investigators who are working to unlock key biodiversity data. While they aren't able to join us in real time, they've provided us with insights from their fascinating work. Turning our attention to our first investigator, Joel, who is head of IT at Smithsonian Libraries and Archives and is working on the immense task of upgrading 60+ million text files by reprocessing them with an open source OCR text engine called Tesseract. As Joel points out, doing so will improve taxonomic search in BHL by at least 17%, and overall his work will improve BHL data quality by approximately 30%. However, processing all of BHL's text files will take time. Joel reports that it will take 2 years to reprocess 263,000 items, and he anticipates completing this task by March of 2024. The remaining challenge that Joel sees is how will we address the handwritten materials in BHL, which, as you can see from his visual, will not benefit from reprocessing with Tesseract. For this reason, Mike Lichtenberg, lead BHL developer and systems architect, has focused on several commercial handwriting text recognition engines that can handle large-scale datasets, and a diverse array of handwriting styles. In his review of Microsoft Azure AI, Amazon Textract, and Google Cloud Vision AI, Mike looked at a variety of factors, but ultimately his decision came down to which HDR engine would significantly increase the number and quality of scientific names in BHL text. After some testing, the clear winner was Google Cloud Vision. To test these engines, Mike used a sample item that had been manually transcribed as his control. The sample item had a verified 555 scientific names in it. Google Cloud Vision was able to capture 133 exact name matches, or roughly 24% of the human transcribed control. It also had the least false positives compared to all of the other engines. Now that we knew Google Cloud Vision was the best, we wanted to see how much it might increase instances of taxonomic names in our archival content. To do this, the BHL Transcription Working Group crowdsourced a 2,000-page sample set across a wide range of materials and found that HDR would increase name instances by an incredible 3,485%. Using bibliographic metadata in the BHL database, Mike was able to extrapolate that over 1 million pages of primary source literature is eligible for HDR. According to Mike, however, HDR processing is not the end of our journey. To turn this data into structured data that can be deposited with big data aggregators, further processing will be required. Additionally, the estimate on the handwritten subcorpus is fuzzy due to a lack of page-level metadata that can tell us whether or not a page is actually handwritten. Realizing that we lacked the page-level metadata needed to isolate which pages to run through HDR, we reached out to Mike Trisna, data scientist at Smithsonian Data Science Lab, to see if he could help us with the task. Mike ran some BHL sample image data through OpenAI's deep learning model called CLIP and was able to rapidly assign page classification metadata to his sample set. As you can see, CLIP data outputs were able to classify a page as handwritten, printed, blank, or containing tabular data or illustrations. Without any fine-tuning, the classifier achieved over 92% accuracy in its assignments. We then asked Mike if it would be possible to process all 80 terabytes of BHL image data using CLIP to better understand what percentage of the BHL corpus is eligible for HDR. Mike thinks a bit of fine-tuning is in order, but from his sample set of 1.8 million images, he found that 1.25% were handwritten and 26.8% contained images or figures. These pages are all candidates for HDR. Our next researcher, Katie Micah, Data Services Librarian at the Harvard Library and the Institute for Quantitative Social Science, has turned her focus to converting text outputs into structured data. She has been able to successfully convert handwritten expedition logs from the Pacific Ocean Biological Survey into tabular data. To do this, she used the coordinates JSON file that is created as a derivative after HDR processing. She then used the coordinates to plot the lines for rows and columns, using them to create a pandas data frame. From there, the data can be output into a CSV. While Katie's work is incredibly exciting, she points out that HDR, while improving, has varying data quality and cannot interpret ditto marks, special characters, or symbols. Additionally, not all species occurrence data in BHL appears so cleanly in columns and rows. This workflow cannot be applied to narrative accounts such as a collector's journal or a diary. To address unstructured narratives containing species occurrence data, Joe DeVere, project manager and museum liaison at Harvard's Ernst Mayr Library, has been running the William Brewster Transcription Project since 2014. In his tutorials for volunteers, he emphasizes the accurate transcription of species names, dates, and locations. A big factor in choosing Digivol as the transcription platform for the journals was its ability to export occurrence data at item completion. Joe has successfully shown that harnessing the power of the crowd is indeed a pathway to extracting key biodiversity data. The William Brewster Transcription Project has generated almost 12,000 transcription files that contain over 14,000 additional scientific names in a fairly short time. And the process is relatively straightforward. Pages are uploaded to Digivol, where they are transcribed, And when transcription is complete, a raw data file can be exported and used for further data processing and deposit. After data processing and mapping to Darwin Core, which we will not have time to cover in today's presentation, the data can be loaded to big data aggregators like GBIF. Joe and I both spoke after we published this data and noted how much it meant to honor the legacy of the great William Brewster, who spent a lifetime documenting New England's natural history and amassing one of the largest private collections of North American birds ever assembled. It feels only right that Brewster's work lives on and can shape environmental policy today in our local region. The promise of liberating data from BHL's handwritten materials is arduous but feasible. To continue this work, increased capacity, support, and an expansion of BHL's transcription efforts will be required. In closing, we'd like to honor the legacy of past collectors and naturalists whose dedication paved the way for our work today. They ventured into the unknown, studying and preserving biodiversity for future generations. Let their spirit inspire our collective mission to protect all life. With sustained support for BHL's data extraction efforts, there are vast implications for biodiversity research and environmental policy. Together, we can forge a harmonious future where every species thrives. Take action today and join BHL staff who are working to build a scalable data pipeline in order to support the preservation and sustainable management of Earth's biodiversity. Thank you so much for your time. I hope to connect soon, and I hope you all enjoy the rest of the conference.
Awesome. Thank you so much. Also, okay, we do have time for a question or two if you're still here, Jacqueline. Sorry, JJ.
Yeah, I'm here. It's very early in Massachusetts, so I'll try and be coherent.
It is very late/early there, but do we have any questions? Well, it seems like you are safe. So we can move on to our next, last but not least, is William Weaver, who should also be online here. Thank you again so much for that talk, Jacqueline. It was really great. Yeah. So like I said, we will have some time for questions.